We will present the packaging process. First, the task contacts and outputs used for the project development are shown. Regarding the main code, there is a Modbus block where the inputs and outputs are configured. The motor driver addresses are set so that it advances, waiting for an undefined tag and thus keeps moving, and the address to stop it. Then the master is configured with its respective inputs and outputs. Next, the motor advance block is programmed with local variables related to global variables, and all the stages are set up to activate them with their respective inputs and outputs, which will be explained later. The next step involves the inductive sensor, which detects screws underneath the disc, allowing us to control the stop at each state. This sensor is present in all stages except for turn oscillator, which depends on whether the inductive sensor detects the cap or not. The data block 0 is programmed to lock the motor activation. Espacio will stop the motor, and data block 2 will stop the entire process and reset all stages. Then there is a block for HMI simulation visualized and circles indicating the current stage. Finally, there is programming to ensure the oscillator does not activate if no cap is detected. A 2-second timer introduces a delay that aids the operation. For the cap placement, when the piston activates, it rotates. After 1 second, the suction activates, the piston returns to its original position, and all conditions reset for the next filling. For the extractor, the filling piston is always active, and the grabber activates 2 seconds later to obtain the cap at the end of the process. The injection activates and deactivates after 1 second to provide a pulse. During a filling, a 5-second timer simulates the filling process, raising a filling down a flag. Next is a more advanced programming where all necessary outputs are activated and a signal is sent as an output. In the oscillator stage, the piston lowers up on activation, and after 5 seconds, the action resets, raising the same down flag. All the used blocks are then listed. Here we can see the main HMI screen design, followed by the system control process screen. Additionally, the HMI tags used in development are shown. For the simulation in factory I/O, the operation is analogous to the disks, but due to software limitations, a conveyor belt was used instead of a disk. A capacitive sensor was used for each stage to stop the stages. In the second stage, there are LEDs indicating filling. In the third stage, there is a state tower simulation, the 3 movements of the piston in sequence to place the cap. The first stage involves selecting boxes when there is no cap. The fifth stage depends on the first, it activates or not. In the sixth stage, the product is finally delivered. And in the physical presentation, the entire procedure can be seen physically along with the HMI. And that's all. Thank you.